Good morning, students. So welcome back. So today we are going to start with the exercise 11.2. Now last time what we have seen? We have seen the area of general quadrilateral. Then we have seen area of parallelogram. Then area of some special quadrilateral. Under that we have seen area of rhombus. Then we have studied about area of polygon by triangulation method. Now using all these concepts we are going to solve some of the examples from exercise 11.2. I am going to begin with third example, that is length of the fence of a trapezium shaped field ABCD is 120 meters. If BC is 48, CD is 17 meters and AD is 40 meters, find the area of this field. Side AB is perpendicular to the perpendicular sides AD and BC. To the parallel sides AD and BC. Side AB is perpendicular to the parallel sides AD and BC. Now, total length is given, means what? Perimeter of trapezium is given, 120 meters. From that, AD is given, CD is given and BC is given. We need to find out AB. Why we need AB? Because it is the perpendicular height. Hence we need to find it out. So what we will do? Perimeter of trapezium ABCD is equal to sum of all sides, right? So we know that perimeter 120, that is equal to AB plus BC plus CD plus AD. Okay, now so therefore 120 is equal to AB we don't know, BC is 48, CD is 17 and AD is 40. So therefore 120 is equal to AB plus, now 8 plus 7, 15 plus 0, 15. So 5, 1 carry on. 1 plus 4, 5, 5 plus 1, 6, 6 plus 4, 10. You can check it. 0 plus 7, 7, 7 plus 8, 15, 1 carry on, 4 plus 1, 5, plus 1, 6, 6 plus 4, 10. Now I want to find AB. So bring this 105 to this side. So when it comes to this side, it will be minus. So 120 minus 105, that is equal to AB. Okay. So therefore AB is equal to how much? Yes, 15. So AB is 15 meters. Now can we find out area of trapezium? Yes, obviously, because I know the parallel sides and I know the perpendicular distance between the two parallel sides, that is height. So I can definitely find out area of trapezium. So area of trapezium ABCD, that is equal to half A plus B into H. Now what is A? One of them is A and one of them is B. Okay. So that means what? What I will write? Half into AD plus BC, that is parallel sides, into height. Height is what? Length AB. Okay. Now, so half into AD is 40 and BC is 48 into AB. AB is 15. Now 40 plus 48, oh yes, 88. Okay, so that is equivalent to half into 88 into 15. So 2 ones are 2, 2 fours are 8, 2 fours are 8. Okay, now 15 fours are 60, 6 carry on. 15 fours are 60 plus 6, 660 meters square. That is my answer. So area of trapezium ABCD, trapezium shaped field ABCD is 660 square meters. Okay, so that is what the expected answer is. Okay, now let's move to the next example. Now see fifth one. The diagonals of a rhombus are 7.5 centimeters and 12 centimeter. Find its area. Now we know area of rhombus formula when diagonals are given. So area of rhombus, that is equal to half into d1 into d2. Simple example. So we know length of the diagonals, both the diagonals. So half into d1, that is 12, into d2, that is 7.5. Okay, 2 ones are 2, 2 6 are 12. Okay, so 6 into 7.5, so 6 5s are 30, 3 carry on, 6 7s are 42 plus 3, 45. Decimal point from left hand side and after one digit. Okay, so 45 is the answer. Okay, so therefore area of rhombus is 45 centimeter square. Okay, now next example, that is sixth example. Now see sixth example. Find the area of the rhombus whose side is 5 centimeters and whose altitude is 4.8. So this is the altitude dotted line I have drawn. If one of its diagonals is 8 centimeters, so one diagonal is given, you are supposed to find the length of the other diagonal. Now here it is sure that I cannot use the formula half into d1 into d2 because only one diagonal is given, other is not given. Now what is given? Length of one side is given and height is given. So do I know the other formula for rhombus? Area of rhombus. Do you know that? Yes, base into height. Okay, so using that, so this is the base, this is the height, you can see here. Okay, so using that I can find out the area of this rhombus. So area of rhombus, that is equal to base into height. Okay, now so what is the base? 5. What is height? 4.8. Now 8 5s are 40, 4 carry on, 5 4s are 20, 20 plus 4, 24. So decimal point after one digit, so 24.0. So 24 centimeters square is the area of rhombus. Now we know another formula. Now I want to find length of the other diagonal. Okay, to find length of the diagonal, I am going to use this formula. Area of rhombus, that is equal to half into d1 into d2. Right? Okay, now, so I know area, I know one of the length of the diagonal. Can I find second? Yes, of course I can find. So, area of rhombus 24, half into d1 is 8. I don't know d2. Okay, now 2 1s are 2, 2 4s are 8. Now, I want to find d2. So, bring this 4 to this side. So, when it comes here, here the sign is multiplication. Opposite of multiplication? Yes, division. So 24 upon 4, that is equal to d2. Okay, 4 1s are 4, 4 6s are 24. So d2 is equal to 6 centimeter. So my final statement, therefore area of rhombus is how much? 24 centimeters square, and length of the other diagonal is how much? 6 centimeters. Okay, now let's solve the next example, that is 8th example. Now see 8th example. Mohan wants to buy a trapezium shaped field. Its side along the river is parallel to and twice the side along the road. If the area of the field is 10,500 meters square and the perpendicular distance between the two parallel sides is 100 meters, find the length of the side along the river. Now what it is given? Side along the river is parallel to, so this is the side along the river and it is parallel to the side along the road. Okay, and most important, this side along the river is twice the side along the road. Okay, and we want to find the length of the side along the river. Now height, the distance between the two sides is given 100 meters, so that is the height. So this is the trapezium shaped field, you can see. Okay, and area of that trapezium shaped field is given 10,500 meters square. Okay, now here this is twice of this. So if I assume this as x, this will be 2x. Okay, so here we'll assume let the length of side along the road be x meters. Okay, so therefore the length of side along the river equals to 2x meter because it is twice of it. Exactly. Now, area of trapezium shaped field. What it is? Oh yes, half into A plus B into H. Now do I know the area? Yes, I know. How much it is? 10,500. That is equal to half into A plus B, that is the two parallel sides, sum of the two parallel sides. So we have assumed them as to be x and 2x. So x plus 2x into height. What is the height given? Oh yes, 100. Okay, now don't cancel here, being there, it becomes easy. Okay, now this 2, when it comes this side, it will be multiplication, and this 100, when it goes there, it will go in division, exactly. So therefore, 10,500 into 2 upon 100, that is equal to x plus 2x, 3x. Okay, now see, 1, 2, 1, 2. So 2 zeros get cancelled. And 105 into 2, that is 210. 2 5s are 10, 0, 1 carry on, 2 0, 0, 0 plus 1, 1, and 2 1s are 2. That is equal to 3x. I want to find value of x. So divide both sides by, yes, obviously 3. So 210 upon 3, that is equal to x. Okay. So 3 1s are 3, 3 7s are 21, 3 zeros are 0. So x is equal to 70. So length of the side along the road is 70 meters. I want to find length along the side of the river. Okay. So therefore the length of side along the river, that is equal to 2x. So that is 2 into 70, that is 140 meters. So my final statement, what they have asked, the length of the side along the river, that is the asked question. Therefore the length of side along the river is 140 meters. Okay. Now example number 9. Now see ninth example, ninth example, top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Find the area of the octagonal surface. Now, one thing to be remembered, it is regular octagon, means all sides are equal. So here this is 5. So all sides are 5 meters. Do you get it? Now, this octagon, we can divide it into 3 parts. So I have drawn here dotted lines. Okay. So this is what? Trapezium. This is also trapezium. And this is rectangle. Now, keep this in mind. This height is 4 meter. This is also going to be 4 meter. Okay. Both these trapeziums, they are going to be congruent. Okay. So if I get area of one trapezium, multiply by 2, I get area of both the trapeziums. Okay. And I know area of rectangle how to find. I know the length, I know the breadth. I can find it out. Do you understand? Okay. And then when we add them total, I'll get area of the regular octagon. So for our understanding or for becoming easy to solve the examples, I have labeled the figure so that it becomes easy. Now here we will say, as it is regular octagon, length of all sides is 5 meters. Okay, now the two trapeziums, trapezium A, B, C, D is equivalent to, is congruent to trapezium H, E, F, G, H. Okay, so if they are congruent, definitely the areas are going to be same or equal. Okay, so area of trapezium ABCD, that is equal to what? Half into A plus B into H. Now, what is A? BC. What is B? AD. Okay, and into H. H is what? BM. Now that is equivalent to half into length of BC. As I said, it is a regular octagon, so all sides are 5 meters. Length is 5 meters. So 5. AD is 11 meters. Okay, that is given into BM. BM height is 4 meters. Okay, so 2 ones are 2, 2 twos are 4. So 11 plus 5, 16. 16 into 2. So that is 32 square meters. Okay, so therefore area of trapezium. Now another trapezium area is also same. So area of trapezium EFGH is equivalent to area of trapezium ABCD. Okay, so that is how much? 32 meter square. Okay, now we can find out area of rectangle. Area of rectangle, what is the name? ADEH. That is equal to, what is the formula? Yes, length into breadth. What is the length? 11. What is the breadth? 5. And 11 5s are 55 meter square. Okay, now I can find the area of regular octagon. So therefore, area of octagonal surface, area of octagonal surface, that is equivalent to area of trapezium ABCD plus area of trapezium EFGH plus area of rectangle ADEH. Okay, now area of trapezium ABCD 32, area of trapezium EFGH 32, and area of ADEH 55. So add them. 2 plus 2 4 plus 5 9, 3 plus 3 6 plus 5 11. So 119 meters square. So final statement, area of octagonal surface is 119 meter square. Okay, so 10th example. Now see 10th example, there is a pentagonal shaped park as shown in the figure. For finding its area, Jyoti and Kavita divided into two different ways. Find the area of this park using both the ways, and can you suggest some other way of finding its area? We also have to suggest some of the ways. We are not supposed to find by that way, but we have to suggest. Okay. Now see here, what is given. So this is 15, this is 15, this is 15. This is a pentagon. This total height is 30. Okay. Now here Jyoti has divided this into two equal parts. You can see this is the midpoint. So we will label that figure. So that becomes easy. Okay. A, B, C, D, E, F. Now here FC, total height 30. So this is 30 meters. Okay, this is 15, this is 15, we know that, and this is 15, but now this is, C is the midpoint of BD, exact midpoint, and so this will become 7.5, this will become 7.5 meters. Now see, both are trapeziums then, and secondly, both are congruent. Why both are congruent? Because why they are trapeziums first? See here, this is one side, this is another side. They are parallel. This acts, BC acts as the height. Same way here. CD is the height, these two are parallel sides. Now, length of these parallel sides is same, height is same. So, area is going to be same. They are going to be congruent figures. Okay, and hence, find out area of one trapezium, multiply by 2, you will get area of the pentagonal surface. Okay, now here, what Kavita's diagram says, this is 15, we know that. This is 15, we know that. This is 15. Okay, now all three sides are 15, this is also going to be 15. It is a square, find out area of the square. Now, this is a triangle. Now, I know the base, what about the height? Yes, total length is given, that is 30 meters. So, till here it is 15. So, left is, yes, so this height is 15 again. So, I can find out the area of the triangle, area of the square, add them together, I will get what? Definitely, area of the pentagonal surface. So, again you can label them P, Q, R, S, T, and this I will label it as U. Okay, this point. So, this is PU. Now, first we will solve for Jyoti's diagram. Find the area for Jyoti's diagram. Area of Jyoti's diagram. Okay, now here we will say segment FC is the divides the pentagonal surface into two equal parts. Okay, C is the midpoint of segment BD. C is midpoint of seg BD. Okay. So therefore, BC is equal to half into BD. That is half into 15. That is equal to 7.5 meters. Okay. Now the two figures form they are trapeziums, and so they are equal in area. So both the trapeziums are equal in area. Okay, so therefore area of trapezium ABCF that is equal to half into A plus B into H. Now half, what is A? Suppose AB, and what is B? That is FC. Okay, and height is what? BC. Okay, so that is equal to half into AB 15, FC 30, and height is 7.5. Okay, so that is equal to half into, so 45 into 7.5. So what we can do, we can divide this further. Better than having two decimal points, we will have only one. So 2 1s are 2, 2 3s are 6. Decimal point 15, 2 7s are 14, 1 remainder, 2 5s are 10. Now multiply 45 into 3.75. So 45 into 3.75. Okay, so 5 5s are 25. 7 5s are 35 plus 2, 37. And 5 is a 15, 15 plus 3, 18. 4 5s are 20, 2 carry on. 7 4s are 28, 28 plus 2, 30, 3 carry on. 4 3s are 12, 12 plus 3, 15. So 5, 7, 8, 6, 1. So decimal point after 2 digits. So it comes out to be 168.75 meter square. This is area of one trapezium. Okay. Now area of that second trapezium is also going to be the same. Okay. So here we will say area of trapezium. Area of trapezium. What is that? FCDE is equal to area of trapezium ABCF, and how much it is? 168.75 meters square. So therefore area of pentagonal surface is equivalent to area of trapezium FCDE plus area of trapezium ABCF. Okay, so 168.75 plus 168.75. So 5 plus 5, 10, 1 carry on. 7 plus 7, 14, plus 1, 15, 1 carry on. Okay, decimal point. 8 plus 6, 14 plus 1, 15, 1 carry on. 6 plus 1, 7, 7 plus 1, 8. And sorry, here it is 168. I took it 16. 168.75 it has to be. I took it 16.75 by mistake. So 5 plus 5, 10, 1 carry on. 7 plus 7, 14 plus 1, 15, 1 carry on. Okay, decimal point. 8 plus 8, 16 plus 1, 17, 1 carry on. So 6, 6, 12, 12 plus 1, 13, 1 carry on. 2 plus 1, 3. So 337.50 meter square. Or you can do it here. 2 into area of trapezium ABC will do. Okay, it depends on how you utilize it. Okay, so area of pentagonal surface by Jyoti's diagram is how much? 337.50. Now we will find out area of Kavita's diagram. Okay. Now area of Kavita's diagram. So as I have said, QRST is rectangle. Quadrilateral QRST is not rectangle, square. Okay. So therefore area of quadrilateral QRST is equivalent to, yes, side square. What is the area? Side square. Now what is the side? 15. So 15 square. 15 square, 225 meter square. Okay. Then find out area of triangle PQT. Area of triangle PQT is equivalent to half into base into height. Okay. Now we don't have the height. So first we'll find out the height, that is PU. Okay. Now we know that this total height is 30 and this is 15. So height PU is equivalent to 30 minus 15, that is 15 meters. So we got the height. Now we can find out area of triangle PQT. Okay. So area of triangle PQT is equal to half. What is the base? Yes, QT. And what is the height? PU. Okay. So that is half into QT. QT is 15 and PU is also 15. Okay. So 2 1s are 2, 2 7.5s are 15. Now multiply that. So 15 5s are 75, 7 carry on. 15 7s are 105, 105 plus 7, 112. So 112.5 meter square, decimal point after 1 digit. Now, so area of pentagonal surface. What it will be? That is equal to area of quadrilateral QRST, that is area of square QRST, plus area of triangle PQT. Okay. Now area of quadrilateral QRST is 225 plus area of triangle PQT 112.5. So that is equal to decimal point 50. Okay. Now 5 plus 2, 7. 2 plus 1, 3. 2 plus 1, 3. So 337.50 meter square. Oh my God. What do you find? Is it same? Yes, it has to be. It is same. So what is the question first? Find the area of this park using both ways. So we have determined. Okay. So here we will say, therefore, area of the park, by Jyoti's diagram is 337.50 meter square, and by Kavita's diagram is also 337.50 meter square. Now the next question is, can you suggest some other ways of finding its area? So yes, we can suggest. I'll come to that. I'll just rub this. So answer to that question, yes, we can suggest some other ways of finding area. Okay, so see here, draw this figure. Okay, so join this. So you get all triangles. So this is one way. So figure 1. And next is in this way. Okay, so this is figure 2. So these are two ways that you can find the area of the figure. Okay, so all are triangles and you know all these sides, so definitely you can find it out. So dear students, today we'll stop here and solve the remaining examples as homework, and we'll meet in the next period. Till then, goodbye. Thank you.